So we're going to be going over the law of sines, which is the first section in the laws of trig unit, which is unit 12. So this is actually a pretty simple topic as long as you know how to solve things that have sine and cosine in them. So to solve a triangle, find missing sides and or angles. If there's no right angle, you can't use the Pythagorean theorem. You can't use just straight trig ratios. You need to know the measure of one side and any two other parts of the triangle. So what I'd actually like you to do right now is cross this part out, and I want you to write down, you need an angle side pair. And what I mean by that is what you'll see in this next slide here. So in this diagram, notice how the triangle is labeled. The capital letters for the vertices, or the angles, are repeated as lowercase letters on the side opposite them. So you have angle A, and you have side A. You have angle B, and you have side B. You have angle C, and you have side C. So when I say that you need an angle side pair, what I mean is that you have to have one set of matching letters. So you have to have both A's, both B's, or both C's. If you don't have one of those pairs, you cannot use the law of sines. So I know what you're thinking. You're thinking, Mr. Sheehan, what does the law of sines actually say? Well, the law of sines states that the ratio of each side to the sine of the angle opposite are equal. So what that says in terms of a formula is that if you take ratios, which are fractions, of each side to the angle opposite it, and taking the sine, so you'd have sine of A, sine of B, sine of C, these are all equal. So if you're talking about something that has two sides and two angles in it, you're going to use the law of sines as opposed to the law of cosines. This is given to you on your reference sheet, so you do not need to memorize it. You do need to realize, though, that sometimes they might use different letters. Like instead of A, they might use E, F, and G, which just means that this would be capital E, capital F, capital G. So you need to be able to manipulate it like that, but they do give you the original one to start with. So looking at a example here. In the diagram below, find D to the nearest tenth. So if we're looking for angle D, we need to have an angle side pair. So you'll notice that they only gave us E and D, but you can figure out F, because the sum of the angles in a triangle is 180. So we can do 180 minus 95, which is 85, and then minus 50, which gives us 35 degrees. So angle F is 35 degrees. And then what I would do is I would just go ahead and label the sides. So this is side F, this is side E, and this is side D, because they're across from those angles. So if we manipulate that law of sines, it would be D over sine D equals E over sine E equals F over sine F. And then I would plug in what I know. Well, I know that angle D is 50 degrees, but I don't know the side, so it will be D over sine of 50 equals, I don't know e, so I would leave it, over sine of 95 equals, I do know f, which is 12.6, over sine of 35. So I'm looking for d, so I need to keep that one in. And the other one that has both things is on the end here. So I'm not going to use this middle one at all. You'll only use two pieces of this in any given problem. So I have d over sine 50, which I could put into my calculator. So I'd have d over 0.7660444431 equals 12.6 over, and I can put sine of 35 into my calculator, and I would get 0.5735764,364, and then I can cross multiply. So I'd multiply these two, I would multiply these two, and I end up with 0.5735764,364 d equals, and when I multiply those other two, it's 9.6521,59983. The last thing I need to do is divide, and you would write this whole thing down again. And I would end up with d equals 16.828 blah 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 blah. And it says round to the nearest tenth. So if I round that to the nearest tenth, my d value is going to be about 16.8, which is my final answer. So again, these numbers are going to look a little crazy because they're super long and obnoxious, but all that is just typing a little more in your calculator, writing a little more on your paper. It's the exact same thing as if it was just one decimal place for each one. You use the same system to solve it, you use the same operations and everything. So let's look at number 2 quickly. What I'd actually like you to do is sketch a picture for this and try and set up the law of sines. You don't have to solve it. I want you to just sketch a picture and set up the law of sines with A, B, and C all plugged in. Other than that, if you have questions on the other problem, please make sure you jotted them down so you can ask me tomorrow when I say were there any questions, and I hope you have a wonderful evening.